There you go. Okay, so today we are learning about quadratic functions again. So we're doing the same types of problems as yesterday, except today we're solving them algebraically. So for a quick review, if you have a study sheet, this is something that would probably be really good for you to put on it. So when we are working with something in the standard form here, what are the coordinates of the vertex? Can someone put up their hand and let us know? Yep, Josh? You got it. P and Q. Okay? And then so we have when A is less than 0, the maximum value is, we're saying, based on this, what would we say the maximum value is? Exactly, it's Q, right? It's always going to be the y of our vertex. And then this is the same thing. When A is greater than 0, the minimum is still Q. Okay? So just by looking at an equation in this form, we know what the maximum and minimum are. So we don't have to use our calculator. And then they ask for the equation of the axis of symmetry. So this is our graph, and this is our vertex. That axis of symmetry is what goes through here. We split it in half. Exactly. So it's x is equal to p. Good work, guys. So, quality study sheet material right here. Okay, so let's go right to example number 1. So this is actually the same problem that we did yesterday, but we're going to solve it all algebraically this time. So the first thing they say is complete the square to write h in standard form. So if we remember, this is the general form. And this is the standard form. I know these names are very specific and tell us lots about it, but okay, so if we're completing the square, Justin, what's that first step that we always do all the time? Justin? You bet there is. So remember, when we're completing the square, we just look for the common factor of those first 2 terms. Okay? Okay? So then, remember, when we're completing the square, we put the bracket like way over here and put the 3 there because we can't forget about that 3, but we're not dealing with it right now. We'll deal with it later. Then this is a really good review for you. Okay? So the next step, that's where we take that negative 12 and we go negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So we add 36 and subtract 36 inside the brackets. So the next thing we want to do is we want to move this negative 36 outside of the brackets. So t squared minus 12p plus 36. And to get it outside of the brackets, we have to go negative 36 times negative 4 is equal to 144. So outside, we'll have plus 144 plus 3. Okay? So when we look at this, we can say, oh, we can make that into a perfect square. So we'll go negative 4, and we know that our perfect square is t minus x squared. And then we just have to simplify this part. So we get plus 147. And this is our equation in standard form. Okay? So this is nice because, like we talked about earlier in the week, we know a lot more when it's in this form than when it's in this form. We know more in standard form than general form. Okay, so they say find the height of the projectile 3 seconds after the launch. So what would we substitute 3 in for? You got it. So we'll go t is equal to 3. So we go h3 is equal to -4. 3 minus 6 squared plus 147. Okay, so we have -4, -3 squared plus 147. Nope. Yeah, it's like y. Like 3 is equal to t and then just sub it in. Yep. I'm just writing it like in the full form for your perfect notes. Okay, so we get -4, 9 plus 147 is equal to -36 plus 147 is equal to 111 meters. Okay? Not off the top of my head. Okay, so for C, they ask us to find the maximum height reached by the projectile. So where do we find the maximum on a graph? The top? What point is this? P and Q, so at the vertex, right? So can I have someone put up their hand and tell me what the vertex is? Yep, Kevin? So the vertex is 6 and 147. And so we know that the maximum height is 147 meters. Okay? And we get that because we know our vertex is point P and Q. And we know that 6 is P and 147 is Q. Remember, because it's always, so if it was T plus 6, then it would be -6 as our vertex. So today's a good review for everything we've learned in this unit. Okay, so can someone put up their hand and tell me how many seconds after the launch the maximum height is reached? We'll let Kevin take this one again. Yeah, awesome. So the vertex tells us not only the maximum height, right there, but also at what time it is. Okay. So then they ask what the height of the projectile is at the launch. So what time do we put in for that? Can someone put up their hand and let me know? Yes, Andrew? At the time of the launch? Yeah. So it'd be time is equal to 0 because it's like right at that second that it starts, right? And so this is basically just our y-intercept if we were to graph this. And we can look at even this one and say, oh, we know that when t is 0, our height is 3 meters. Okay? And then for the last, or second last question, determine when the projectile hits the ground to the nearest tenth of a second. So we know that this is our x-intercept, right? And even though there's two x-intercepts, are we dealing with both of them? No, because we'll find out in a second that one of them is negative. And so we don't deal with negative time, so we don't care. So for this one, there's two things, or two ways you can tackle this problem. You can make this equal to 0 and go 0 is equal to -4 p minus 6 squared plus 147. Or you can use this one. So you can go 0 is equal to 4t squared plus 48t plus 3. And if you decide to use this one, you can use your quadratic formula. So I think that's the easier of the two roots. So that's the way that I'm going to do it. So we go a is minus 4, b is 48, c is 3. So we get t is equal to negative b plus or minus b squared minus 4ac over 2a. Okay, so we'll get negative 48 plus or minus 48 squared minus 4 like that. Okay, and then so when we start to solve this, we get negative 48 plus or minus, and under the brackets we get 2,352 all over negative 8. So because they're asking for it in seconds and to the nearest tenth, that means we're looking in decimals, which is awesome because then we don't have to worry about common factors. We don't have to worry about simplifying the radical. If they're asking for it in decimals, you can just punch it all into your calculator. Okay, so there's two different answers. We get t is equal to negative 0.1 and 12.1. And we've already talked about how negative time for this type of problem does not exist, not possible. Okay, and so our answer is 12.1 seconds. Okay. So if we do class example number 2, so they say a rancher has 300 meters of fencing with which to form a rectangular corral. If you don't know, a corral is like a pen for animals. So they say one of those sides is an existing wall which does not require fencing. So maybe it's built up against like a barn or something. So we only have to build 3 sides of the fence. If you were, say, writing a diploma exam and they said one of those sides is an existing wall, they will not usually have that line written, but they expect you to be like, oh, one side's a wall. I don't need to build a fence where there's already a wall. Okay? I don't know. Can you have bigger problems? Okay, so they say 2 of the sides of the rectangle are x meters in length. So we know that it's these 2 sides because it's a rectangle, right? So we know it's not going to be like that because this side and this side are going to be equal. So when they say 2 are the same, we automatically know it's these 2. So, and then they say that the area can be expressed in this form. So area. Okay. So what's the equation for area? Just the general equation. Yeah. So we can say that this is equal to length times width, right? Because we already know that this is area. And so in our problem, we already know that, say, the width is x, right? Because they gave that to us. And we'll say that length is length. So we can go 300x minus 2x squared is equal to L times x. And so to find the length, all you have to do is you want to isolate it, so you can divide both sides by x. which simplifies this. And you get that the length is equal to 300 minus 2x. Okay, and then you can check your work by going, okay, area is length times width. We have length is 300 minus 2x times x. 300x minus 2x squared matches with that. Perfect. Okay, so now they're asking us to determine what the maximum area of that pen could be. So we can complete the square and find our maximum. So yeah, this is like checking our work. So check. Yeah, that's usually what you do when you check your work, is you kind of do the question backwards. Yeah, but in this unit we're doing everything algebraically, or for this lesson. Okay, so they say use the method of completing the square to determine the maximum area possible. So we'll go, okay, we know that our area is 300 minus 2x squared. And we're just going to rewrite this in the way that we usually deal with things. Yes, thank you. Okay, so all I'm doing is changing the order so that we have it in the form that we like to have our quadratics in. And so, Justin, what's our first step? You got it. Oh, missed it again. Yes, 300x. So our GCF is -2. And then we go x squared plus 150x. And we close that bracket way over there. Okay? But remember, so when we say what we're taking out isn't actually the GCF, it's just a common factor, because we want to keep an x squared in there. Because when we're completing the square, we need an x squared in there. So this isn't quite the same as factoring, we're just setting ourselves up for the situation we want to be in. Okay? So when you're completing the square, you will never take an x out, you will only take a number out. Okay? So then we go 150 divided by 2 is 75. 75 squared is 5,625. So we get to add that. And we get to subtract that. Okay? Good. Okay, and then so that next step that we have is we always want to take that minus out of the brackets, right? So we're going to multiply it by -2 and then stick it on the end. So we have -2 x squared plus 150x plus 5,625. And then we have plus 1,100 or 11,250. Okay, so because we have a negative here and here, we get a plus there. Okay, and then so the last step is just to complete the square. So that's that part. So we get -2 x plus 75 squared plus 11,250. Okay, so we've completed the first part of the question. Now they ask us to determine the maximum. So, can someone put up their hand and tell me where you find the maximum on your graph. Yes, Josh? At the vertex. Can someone put up their hand and tell me what the vertex is? Yes? P and Q. And so? So, I have a quick mistake in the notes I'm just going to make a correction to. When you take negative 2 out, you get negative 150, like that. So you'll get negatives all the way down there. Okay, so our P and Q is 75 and 11,250. Yeah, which is why we would do this algebraically. Okay, so this is the maximum area. Okay, and this is our x to find that maximum area. Okay, so then they just ask us to state the dimensions of the rectangle, which give the maximum area. Okay, so we know that our length here is 300 minus 2x. So our pen is x by 300 minus 2x. And we know at the maximum, x is equal to 75. So it's going to be 300 minus 275. So we'll get, for our final answer, it's 75 by 300 minus 150. No, not for this part. That's for the equation of area, but this is just our length here. Okay, because they're asking for the dimensions. Okay, so for one last example. Oh, dang, Ashley's not here too. Ashley was asked by her math teacher to find two numbers which differ by 8 and whose product is a minimum. So, if x is the smaller number, how can we write what the bigger number is? We know that they differ by 8. You got it. X plus 8. Okay? And then they ask us to write an equation for the product of that. So what does product mean? Can someone put up their hand and let us know? Yeah, Kelsey? Yeah, it means we're multiplying. Okay? So we'll say that the product is equal to x times x plus 8 is equal to x squared plus 8x. Okay? So again, they ask us to write it in the completed square form. So we go x squared plus 8x. This one's a nice one though, because they don't have any common factors and they don't have anything here. So we get to eliminate 2 steps that we normally have to deal with. Okay, so we start off going like this. We go, okay, 8 divided by 2 is 4. 4 squared is 16. So we get x squared plus 8x plus 16 minus 16. And all you have to do is put brackets like that. And then you'll get x squared minus 16. Yeah, so this one's nice and easy because we don't have a common factor and we didn't have anything here. No. That's what I just said. Okay, so then they ask us to find the minimum. So where on the graph do we find the minimum? So because the calculator means you're not using your brain. Okay? Because people that don't know anything about what they're actually doing can solve these problems on a calculator. Okay? If you can solve it algebraically, then I know for sure that you know exactly what you're doing and you know what all these numbers mean. And Sam, I don't know why you're talking at all right now, because I'm talking, so that means you're not. Okay. You can be respectful by listening and not talking. Okay. So for the last little bit, they say determine the numbers and the minimum product, which is our vertex, which is our P and Q. So can someone put up their hand and let me know what P and Q are? Yep, Kevin? Is it 4 and negative 16? Remember, it's going to be negative 4 because we always go x minus negative 4 squared minus 16. So this is a good unit or good lesson to end on because it goes back to our very first lesson in the unit, right? So our minimum product is negative 16. We know that x is equal to negative 4. And so x plus 8 is equal to 4. Because that was our two numbers in the beginning. Or actually, here I should say. Okay? So we know our two numbers are negative 4 and 4. And the minimum product is negative 16. And that's our final answer. Okay, so for homework today, we're doing number 1, number 3, and then 5 to 7. Okay, so in other words, you can say omit 2 and 4. Okay, and that is lesson number 8.